Hello and welcome to R&D Math. Now here we are going to do some problems. Now how do we see? If I were you, I will break down this problem like there are different size of triangles. I would say this size is size 1 and something like this, that's size 2, and something like this, that's size 3, and the largest one, that's size 4. Now size 1 triangles. How many numbers are there? How many triangles are there? Now, first one is easy to count. Actually, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And size 2 triangles, well, I can see 1, 2, 3, 4, 5, 6, 7. Did you see 7? So a place to miss is actually one place to miss. See, you have 1, and then the next one is actually these two. This one and this one, right? And then like that you have another, and something that people can miss is this right here, upside down triangle. Okay, and size 3 triangles, I can see 1, 2, 3, only 3, and size 4 triangle 1. So 16, how do you add these numbers easily? See, these two 10, and 16, 26, and 27 is the answer. Okay, next. Now this problem has some word issue. Now let me, first angle, it says measure of one angle is twice the measure of second angle. So second angle, if I take it to be x, then this guy is 2x. And the measure of the third angle is 12 degree more than the first angle. So first one I took 2x, so 2x plus 12. If we go with the wording, so then you have here 2x. So when you add this, and this, we get 5x plus 12 equals 180. And then 5x equals 180 minus 12, which is 168. So x, 3, right? And then 2x is going to be 67 this, and 2x plus 12 is going to be 67.2 plus 12, and we are going to get 79.2, right? But sometimes with this wording, see, if I believe it's better to avoid this term and go with smallest angle, because naturally there is a tendency when students look at this problem, they will take, okay, first, second, and third. Oh, smallest, next, and largest. So it says something is x, something is 2x, and then in that case you take like this. So if you do it like that, then we are getting this answer. So 4x equal 168. Now we are dividing x by 4. So 4 and 2. So 2x is 84. And 2x plus 12 is 96, right? Well, no, 2x is 84 and the other one is x plus 12. So it's 54. So the largest in that case is 84. In this one is, so if we go with the wording, this is actually the answer. And next one, okay, Samuel, Martha, James. Okay, now 5 friends. So what are the conditions here? James insists on sitting on the aisle. Now let's keep that aside and look at the other condition, Samuel and Martha. So S-M-O-M-S, we don't know which order. Raphael sits next to Samuel and next to James. So Raphael in the middle, right? Next to Samuel and James. Oh, right. Now if you have this, then the second condition, we cannot have this, right? So we have to have this, if that is the case. So in that case, SMJRS. Now if we have this case, then in that case, we cannot have this. We must have this. So in that case, MSRJ. Now then, so I think I made a mistake here. No, see, if we have this, sorry about that, we cannot have this one, we must have this. So JRSM. Okay, JRSM. Now it's about KT. Where do I put KT? Now if we forget about this condition, the aisle condition, we can put KT here. Well, but since we have in the aisle condition, okay, don't forget about that, sorry about that. So sometimes there are ways of attacking the same problem in different ways. So in this case, James insists on sitting on aisle. So James has to be on a corner. So this is not a possibility. So, and in this case, again that. So in any case, I see two different arrangements. In any case, who is sitting next to Katie? Martha. Right. Okay. I hope you understood that. Next one. Now this is about toothpicks. This looks like the first problem. Now in this one, how do you arrange this? How many toothpicks are required to form a triangle with 10 toothpicks on a side? So this is one toothpick on a side, this is two toothpicks, this is three toothpicks. So how do you see this problem? What is the easiest way? So what I see is first one, okay, just three toothpicks. Second one is actually three triangles. Can you see that? Second one is this. If I arrange three triangles, see, like this, three triangles with toothpicks like this. If I bring them closer, I get this figure. Can you visualize it? Right. So here I'm bringing them closer. So three triangles, visualize it like this, like this triangle, and this triangle. And yes, of course, there's a middle triangles forming, but it's automatically formed, right? For three, what I'm doing is, okay, at first step, one triangle, and at the second step, two triangles, and the third step, three triangles. So now you see the pattern. For 4, you add another row. So what you are doing is, the easiest way to approach this problem here. So number of triangles. Here you have 1, here you have 2, 1 plus 2. Here you have 1 plus 2 plus 3, and then you see the pattern, right? For 10, you are going to have 1 plus 2 plus up to 10, right? And then you know the formula for this. We learned that. So number of triangles for 10 toothpicks. Number of triangles is 1 plus 2 plus all the way up to 10. So that is n into n plus 1 divided by 2, which is 55. But for one triangle, that's number of triangles. One triangles, we need 3 toothpicks. So 3 into 55, 165 is the answer. So if we generalize this, n on side, so n on a side, if we generalize this, so 3 times n into n plus 1 over 2. That is the formula. Okay. Now this one, interesting one. Now, first, this part is shaded and that is 1/4, right? And then you take this and do the same thing again and shade it. So that is actually 1/4 of 1/4, which is 1/16 or 1/4 squared, right? And you do that again. So that is 1/16. This part is 1/4. This part is 1/16. So 1/4 of 1/16. So 1/64 or 4 cubed. And that's all it has been shaded. So the answer is actually so 1/4 plus so 16, 64. 64 is the common denominator. You need 16 here, 4 here, and 1 here. So 21 or 64 is the answer. But I would like to take one more step and I challenge you. What if this pattern keep continuing? If I put some dots like here, if I rearrange the problem, what if it keep forever, like infinity process? Then what fraction? Can you figure it out? Try it and you can make a comment. Okay, next problem. Now Fibonacci. Now Fibonacci sequence. First of all, let me talk a little bit about Fibonacci sequence. Fibonacci sequence means 1, second number also 1, and then you keep adding 1 and 1, 2, and then 2 and 1, 3, and 3 and 2, 5. So to get the next number, you keep adding the previous two numbers, 8, 13. This is the original famous Fibonacci sequence. Now here in this problem, Fibonacci type. What do we mean by Fibonacci type? Look at the first one. See, 1 and 4, you add this, you get 5, and then 5 and 4, you get 9. So the next one, 14, 14 and 9, 23, and 23 and 14, 37. Right? See, even the last one, it's given as a, it doesn't asking you anything, but see, 3 and 7, 10, 7 and 17, and like that. See, you can create your own Fibonacci, like you can start anywhere, let's say 2, 5, and then you have 7, and then you have 12, 7 and 12, you get 19, and 19 and 12, 31, and so on, right? 50, like that. Now, part B, 2 and 6, so I need to have 4, and 4 and 6, 10, 10 and 6, 16, correct? So you have 36. Number C is little tricky because you don't see anything in the middle. Now you have to figure it out. Well, at this point, there are two different techniques I can see. One is an educated guess, right? For example, if you put a little number here like 4, it will not work because 4 and 3, 7, and 7 and 4, 11, and then 11 and 7, it's not, it's 18. So you have to have a much larger number. So you can guess and play it. Oh, you can put like x. If that is x, this guy must be x plus 3, right? And this guy must be x plus 3 plus x, which is 2x plus 3. And 27 in that case must be this guy plus this guy, which is 3x plus 6. And then you just have to solve this. So 3x is going to be what? 21. So x is going to be 7. And let's check. If I have 7, then I have to have 10, then I have to have 17, then I have to have 27. See, correct. So those are the answers. Now this one, part A. 3, 6, 9, 12. So it's just, so see, 3, and the next one is twice 3. Next one is 3 times 3. Next one is 4 times 3, and so on. So the general term, 3n. It's so easy. Part, let me keep part B and do part C first. Part C, look at this numerator 1, 2, 3, 4, 5, and it keeps so n. Denominator 3, so 3, and here 3 squared, 3 cube, 3 to the fourth, so n over 3 to the n. That's the general term, and you can easily find these terms by plugging n equals that value. And I'm interested in part B because it's, let's see, let's first do it. 4, how do I get 7? Well, by adding 3, and then I'm adding 4, and then I'm adding 5. Now you can see the pattern. And then I'll add 6, so 22, and then I'll have to add 7, 29. So it's asking you to find the sixth term with that, which is easy. 8, so 37, and then add 9, 46, first, second, third, fourth, fifth, sixth, seventh, eighth. We can, since 12 is not a large number, we can keep doing that. So ninth term is going to be 56, and then 10th term is going to be plus 11, so 11th term is going to be 79, and the 12th term is going to be 92. Yes, 92 is the answer, but now I'm actually more interested in finding a general term. Because what if I ask you to find 100 term? How do you do that? Now, how do you generalize this pattern? This is a little tricky. Now, let me try to address this. Let me write down the problem again here. Well, if you want, you can choose this to be the first term, A1, and go A2. But I would like to actually, sometimes in mathematics, we can do things, we can modify our problem to make it an easier problem. I would write down one term before that. Here I am adding 3, right? Here I am adding 4 and 5 and so on. So what do I have to have here in order to get to 4? I must have 2, right? And then from here, I must have 1, right? Now, look at these numbers carefully. Now, if I call this guy A1, let me write down A1 is 1, and A2 is 2, which is 1 plus 1. A3 is, well, A3 is the third term of our modified sequence. In our original sequence, it's A1, right? So remember that. So it plays a role about this 12th term because I modified it in order to catch a pattern. A3 is 4, but that 4 is 1 plus 2. We'll have to write down a little bit more in order to see a pattern. A4 is 7, that is 1 plus, see what I'm doing is 1 plus this. 1 plus, I'm choosing this path to get to that, this. So 1 plus 1 plus 2 plus 3. Now we have a pattern. A5 is this guy 11, but it comes, using this direction, starting from here, keep adding the next numbers. 1 plus 1, sorry, A5 is 11, and that is 1 plus 1 plus 2 plus 3 plus 4. So you always have this 1, see 1, 1. If you forget about that one, then you see a nice pattern. It's 1 plus 2, 1 plus 2 plus 3, 1 plus 2 plus 3 plus 4, and like that. So for fifth term, you know what, let me write down the sixth term, then it's, so sixth term is going to be 1 plus, and then let me put a parenthesis, 1 plus 2 plus 3 plus 4 plus 5, right? Because if for 5, you had here 4. So for 6, you must have 5. So now we see a pattern. AN, nth term is going to be 1 plus 1 plus 2 plus up to n minus 1. Now this guy we know, well, if we add up to n, that's n into n plus 1 divided by 2. But since we are adding up to n minus 1, this n minus 1 times n minus 1 plus 1, it is n divided by 2 plus 1. So that is AN. Now plug in n in this sequence will give you whatever the term you want. But our original sequence is starting with 4. That means here. So that is our A3. So if you want 12th term, what does that mean? If you want 12th term, see, now A1, let me address this. Let me erase these things. Now here, 1, 2, 4, 4, 7, 11, 16, 22. That is the problem given to us. Now this is the first term, right? But that is A3 in our sequence, right? So in this term, 12th term means in our sequence, it's 14th term. Does that make sense? See here, the second term in our sequence, that's the 4th term, right? So when you plug 14 here, 14 minus 1, 13, 14, so 7, 91 and 92, see the same answer. Okay, that's a little tricky one. And also, I recommend you, see, can you do it like without modifying it? Well, when you modify it, you can see the pattern, but then you can write down a general term for the given sequence. How can you do that? Well, you just have to rearrange this a little bit because my third term is the first term of the given sequence. So it's just jumping 2. So try to figure it out. That's as an exercise. Okay, next. This one is not that hard. So please read the problem. You can pause the video and read. This is 90 degrees and it says the other angle by the walkway is 3 times the third angle. So if this is, see, this is the walkway, so this is 3x. So 4x plus 90 equals 180, which means 4x equals 90 and x is going to be 22.5, right? What are the measure of the angles of this flower bed? And 3x, that is going to be this, and the other one 90. These 3. That's pretty easy. Okay, now this problem, this is little tricky, little challenging. Now carefully read the problem. So there are 2 conditions. First, actually 3 conditions. Can you see those 3 conditions? Now let me choose 3 different colors. Center region must be yellow. That's the first, not the first, that's one of. And no 2 boundaries can be same color. That's the second. And the third one is this part right here, this part. All the colors to be used. Now let me forget about that for a second and address this problem. Now, see, this must be yellow. So yellow. And then I have 1, 2, 3, right? What is the easiest way? Well, there are many ways. This is what I would do. Yellow. This guy, let me call region 1, 2, and 3. Region 1 at this level. Region 1. So region 1 can be either blue or green. Why? Because it cannot be yellow. Yellow and yellow is not permitted because the boundary in region. And then, sometimes in problems like this, it's easy to think by avoiding some conditions. Say, for example, I decided to avoid this condition first for a reason and then do this problem. And if my region 1, this region is blue, then for region 2, I have choices yellow and green. And for this, yellow and blue, right? And that's my region 2. And for region 3, if this is the case, then I have yellow. It must be the other two. So blue and green, yellow and blue. And here blue and green. And here yellow and green. Now this is the tree diagram. But see, now I can see 8 possibilities. See, this is one possibility. That means yellow, blue, yellow, blue, something like that, right? But so like that we have actually 8. But now let's address our condition that I forget about. The first condition, all the colors must be used. So if you think about this one, this first possibility, this one right here is not possible. Can you see? Because all the colors are not used. Green is not used. So that is not a possibility. Second possibility goes like this. So that's okay, right? YGB, all of them are there. So you just have to check. So let's say YGB, and yes, that's good. BGBY, that's good. BYG, that's good. GYG, that's not good. See, this path. Let me choose another color. See this path. GYGY, no blue. So that's not good. And the others YBG, that's good. GBGY, that's good. So out of 6, out of 8, we have to get rid of those two. So 6 is the answer. Next problem. Now this one, can you see the pattern? Again, pause the video and think about it. Now first figure, I have only one. Second figure, I have 1, 2, 3, 4, 5, 6, right? How do you get 6? So in the base, I have 4 of them, and then on top, I have 2. But I need to break this down. 4, I get 2 by 2, right? So 2 by 2. And then here, this guy is 2 by 1. And for the third one, I get, see, this level, basement level, base level, that's 3 by 3. And then I have 3 by 2 plus 3 by 2 and plus 3 by 1. Now you see the pattern. 3 by 1. Yep, 3 by 2. So the fourth one is going to be 4 by 4 plus 4 by 3 plus 4 by 2 plus 4 by 1, right? And the fifth one, same. But rather than writing this, we can see a pattern if we do some math. In these 3 terms, I can pull 3 out. So I get 3 plus 2 plus 1. Here the same thing, 4 out, 4 plus 3 plus 2 plus 1. So what I am getting for 5, 5 into 5 plus 4 plus 3 plus 2 plus 1. And this is n times n plus 1. So 5 times 5 into 6 divided by 2. So I'm getting 75. Now how do I generalize? N into n plus 1 plus 2 plus all the way up to n. So n into over 2. That is the answer. And Okay, guys, that's it, and thank you.